In this video, I want to discuss how to factor quadratic expressions. So, a quadratic expression is expressions that look like this. They basically have a squared term. Okay, so there's a quadratic expression. There's another quadratic expression. There's a third quadratic expression. So as long as it has variables squared somewhere in the expression, we call it a quadratic expression. All right. Now, you can't it still has to be a polynomial. So let's get that clear. It's a quadratic expression is a second degree polynomial. That's very specific. All right. So we know how to factor cases that don't have a quadratic term. What about if they have a quadratic term? So let's talk about that. And to understand this video, you'll have to know FOIL. You might want to review that if that was a little rusty. But for our first example, let's do this. Alright, so we want to factor that. Now, what's going to help us is that we know that we're going to have two parenthesis blobs multiplied together. So we're going to take advantage of the fact that the factorization of a quadratic expression will always be two binomials, as they're called, multiplied together. A binomial is a polynomial with two terms. Okay? So here we go. So think about what FOIL does and think about working backwards. So we're trying to think of what we're going to put in the parentheses so that when we FOIL, we're going to get back to our original expression. So we know that the F in FOIL means we have to multiply the firsts together. What if I put an X at the beginning of both? Because that's when I do the F in FOIL, that's going to give me the X squared, right? Which is good. And then we know that the L in FOIL means that the lasts are going to multiply together. So we need something to get the number 4. What about if we put two 2's? All right. Now, you can FOIL that out, and you'll see that by luck, I happen to also got the middle term correct. Okay, now that middle term is the hard part of factoring quadratics, if there is a hard part. Okay, let me show you another choice that would have also given you the first and last term. Okay, so notice that the F in FOIL on this second factorization would give the X squared, and the L in FOIL 4 times 1 would give the 4. Okay, however, if you actually do FOIL it out to check, you will see that the first one gives what we want, and the second one, FOILing it out, which I'm assuming you know how to do, the second one does not give the correct middle term. Right? So the big question now is, well, how do I know if I have the correct choice that'll give me the correct middle term? Okay? So the painful answer will be, well, just FOIL everything out and see which one is correct. Okay? A quicker way would be, if you think for a second, you might be able to do part of the work in your head. So the I and the O and the I in FOIL are the inners and the outers. So that means you're going to multiply the inners, the 2 and the, that's going to give you a 2x, and then the outers are going to give you another 2x. Now go ahead and add those products in your head. 2 apples plus 2 apples, that gives 4 apples, right? Okay, on the second one, 4 apples plus 1 apple gives 5 apples. That's why we have a 5x. Okay, this is just a little cutesy way to try to do part of the foiling in your head really quick to see which candidates you can discard. All right, and it is possible to have lots of choices that you have to sort through. Let me do another one. What about if we had this? Okay, so we do what we did before. So we know that maybe x and x would be a good choice. And then we ask ourselves, what multiplies to 12? Well, let's see. 3 times 4, so 3 and 4 would work. 12 and 1, that would work. Okay, 6 times 2. Right? Okay, so now, is that all of them? I believe so. There you go. So now you have 3 choices. Okay, again, you could FOIL out all 3 and that'll reveal which one is correct. Or if you can kind of do part of the FOIL in your head for the middle term, you'll see that the second one is the one that is correct. All right. Now, if you're having trouble seeing the way to do the middle term in your head, by all means, do a couple of them where you write it out. Okay? You do a couple of those, and maybe after working a couple out the painful way, then it'll click. Okay? So that's the our introduction to factoring quadratics. Now, what about if we wanted to factor something with a negative sign? Let's see, how about this? Okay, so now you need to ask yourself what multiplies not to 8 but to negative 8. How about minus 4 times 2? How about 4 times minus 2? All right. How about 8 times minus 1? How about minus 8 times 1? All right. So as you can see, if you introduce the negative, or if the middle term is negative, if you need to consider negative products, then you're going to have potentially a lot more choices to consider. Okay. This time when you try to do the inners and outers, you might end up subtracting the products. Okay, you should see that. Let me just see if you can do just the middle product in your head. So I'll go ahead and write the middle product of the first choice is going to be minus 2x. I just did that in my head. See if you can do that. The second one, the middle choice, would be 2x. The next one, 7x. The other one, minus 7x. So the answer has to be the last one. Okay? That's how that is done. Now, let me bring to your attention some special situations that you might see. Okay? This is a majority of what you need to know to factor quadratics, but let me now give you some fun facts related to this. All right, watch this one. Okay. Actually, instead of me doing a new one, let me go to this one that I did. What I want to bring to your attention is, notice that the solution for this one, let me write it, let me copy it again. The factored form is x plus 2 times x plus 2, which you can write as x plus 2 squared. All right. That will be referred to as a perfect square. All right, just like 4, 9, 16, 25 are perfect squares because they have nice simple square roots. These are it's a similar idea. These are also perfect squares in the sense that they have nice factorizations. Nice, they're just the same binomial squared. All right, so you will see that. Now, if you want to know when that's going to happen, this is not the most important information although it will be useful later. But if you want to know when you're going to have a perfect square, it's when the second, or it's when the last term is the square of half of the middle term. Okay, so the middle the middle coefficient, I mean. So the middle coefficient was 4, half of that's 2, 2 squared is 4. Okay? If you understood that, you should be able to generate other quadratics that'll have perfect squares, that the two pieces will be the same when you factor it. So here's a couple more. Okay, this one's going to give x plus 4 squared. You can convince yourself that that's true. This one's going to give x plus 5 squared, and we could do other examples, but hope you see that the second, the last number, the 16 and the 25 it's the square of half of the middle coefficient. All right. So again, perfect squares. Okay, another interesting situation is, what if you don't have 3 terms in the quadratic? Okay, so for example, something like this. How would you factor that? Well, in that case, you just factor out the x and you get that. Okay, so that's we did that in previous homeworks. More interesting is, what if you had something like this? What if you had the middle term missing, the x term, and you were subtracting? All right. How would you factor this beast? All right. If this looks like something that's going to take new skills, let me suggest one way to interpret this in terms of what you know. All right. Wouldn't you agree that this is the same as if I had a 0 for the middle coefficient? Okay. So now it looks like a quadratic with 3 terms. Go ahead and do what you already know. If you were trying to factor the black one, you would start with x's. You would have to multiply the -4, and they'd have to give you the 0 term in the middle, and so you would end up realizing that that's the correct factorization. All right, that's one way to understand it. What's cool is, when the middle term is missing, both parenthesis pieces, the numbers will be this. They'll be just the same number but opposite signs. All right, inverses of each other, however way you want to say it. Okay, so that's when the both are the same. When both binomials are the same, we call that a perfect square. This one, when this happens, where you have the numbers that are inverses, this is called the difference of squares. Okay, let me give you some other examples of the difference of squares. What about like x squared minus 25? That would be, you can factor that as x plus 5x minus 5. X squared minus 64 would be x plus 8x minus 8, and on and on. Okay, now what if you didn't have a difference? What if you had the sum of squares? Well, then it won't work. You won't be able to factor it if it's the sum of squares, only if it's the difference. Okay. All right, and then the last thing I want to talk about is, how do you factor something where you've got for the x squared term is a little bit more complicated. All right, so all the examples that I've given you so far, I've had the first term is x squared with a coefficient of 0, right? But we don't always have to expect that the coefficient in front is going to be 0. For example, what about this animal? All right, how is that 2 going to change things? How are we going to factor this? Okay, well, it's basically the same idea. You're going to have, again, 2 binomials multiplied together. When you split the first term into 2 pieces, because it's more than x squared, you're going to have a number there, so you're going to have a number in the first pieces. So what are 2 factors that multiply to 2x squared? How about 2x times x? You see that? Okay, and so that's what so it'll involve numbers in the beginning, so just think about that. And then this one, there's only one choice for what multiplies to give 1, so you can FOIL that out now and you will see that that is indeed the correct answer. Okay, so go ahead and work that out now if you like, and I want to conclude this video by showing you the most difficult type of factoring that you will see. Okay, so what if we had something like this? What if we had 12x squared plus 4x minus 8? Okay, so this allows me to bring up 2 points. First of all, if they all share a common factor, that's you want to rejoice, because here that means you could make your life a lot easier with smaller numbers. So we can factor out the 4 and have 3x squared plus x minus 2. So now you just have to factor that easier quadratic in the parentheses, the red one. All right, now it's still going to be fairly difficult because of that 3 in front of the x squared, but at least it's not as difficult as the original one. Okay, so remember that you can pull out a common factor. Okay, now let's go ahead and try to, but now the 4 has to follow along for all the guesses. So 3, you could split that into 3 times 1, 3x and x, and then the 2, the minus 2, that what multiplies to minus 2? Well, you could have 2 times minus 1, or you can have minus 2 times 1. All right, so go ahead and FOIL those out and you'll see that the last one is the correct answer. Okay, now let me make one thing clear. Okay, suppose that you didn't see that you could factor this. All right, let's just try to do the original one, and it is possible that you'll have some that you can't factor. Okay, on the original one, keeping the 12 and the minus 8 there. So what multiplies to 12? Well, 3 times 4. What multiplies to 8? Well, how about plus 4 minus 2? But what else multiplies to 12? How about 6 times 2? And then what else multiplies to 8? How about 8 times, or minus 8? How about 8 times minus 1? All right. Now, not only do you have to consider the possibilities that I've written down here, but you also have to consider that the order matters now. So for the first one, I did 3x and 4x. Okay, it's going to be different if you do 4x and 3x. Okay, FOIL out both of those, and both of those candidates, I'll put them in the little rectangle. You'll see that they both give a different answer. Okay, so the point that I'm trying to make in this, as I close this video, is it's entirely possible that you will have a stinking lot of things to check out. Okay, I don't even think I might be approaching half done, but there's several more that you might come up with. Okay, so you'll have to check all of them to see which one is the correct one. That's why I said when you have a coefficient in front of the x squared that's not 1, they get a little bit more difficult. Now, as you do more and more of these that have these, like this purple list, you'll be able to, in your head, you'll be able to see, okay, well, obviously this won't work, and so you'll do a little faster. But I just want to say right now up front that yes, these are tedious. Yes, they're going to take a long time. So when you do these on the homework, if you have a bunch to check, don't think that you're the only one. Okay, even when I do it, it's annoying.